IE12, this is a video on section 1B, and as you know, the section is on AP, or the arithmetic progression. That's what it stands for, AP. That means arithmetic progression. The word here, the progression, means basically sequence. Okay, so another way of saying sequence. So I don't know why they don't say AS, but they somehow for the short notation, they just use AP to mean arithmetic progression. But here the progression means the sequence. Okay, so question 2. So you were told that the first term is 7 and the common difference is -4. So to generate the first 4 terms, the first method is you can write down the general formula for that particular sequence, which is the AP. So therefore you can use that formula. Okay, so then you do all that, then you get that for the nth term. Then you substitute n equals 1, 2, 3, and 4 to generate all of this. Or, since it's asking for the first 4 terms, what you could do is, rather than using that formula, what you can do is, okay, that's the first term. The next term then will be adding -4 on top of that. So, which is that. And the third term is adding the -4 on top of 3 to get -1, and so on. Okay, so I guess in this sort of question, to do this is the second method is easier than generating the nth formula and then write the 4 terms down. Okay. All right, the second one is, this time the first term is negative and the common difference is positive. So, but the principle is the same. You just have to keep adding the common difference to the previous term to generate the current term. So that's that. Okay. All right, question 3. So here you weren't told whether this is the A is an AP. So you first of all need to work out whether the sequence or the progression is actually an AP by checking out the common difference between those two and those two. And if they're the same, then yes, you can say that that's an AP. And that's exactly what I'm doing here. And turns out the difference between the first and the second term, and that between the second and the third term is the same. Hence, we can conclude that it's an AP. Okay. Again, it's not good enough to say, okay, therefore the differences are the same. You have to actually make a next statement that is, therefore the sequence is an AP. And hence, we can say that the first term is -12 and the common difference is 5. And later on, you can now write down the formula for it using the AP formula. We're going to have a look at that later. So part E, the same. So here you've got these, and you got to work out the difference first between these two and those two. And turns out they're not the same. So hence you conclude that this is not an AP, therefore you forget the rest of it. Okay. All right. Next one. So this time the question 4. So you were told that this is basically an AP. So the first term is 7 and the common difference given is 6. So you use the formula that is the A plus n minus 1 times D, the common difference. Then you do the usual expansion and then collecting the like terms to get that. Hence, you can now work out the 11th term. Okay. And in this case, this is easier, faster that way, by generating the nth term formula and then substitute for that particular n. Because if it's asking for the third or fourth term, then it's easier to just keep adding the 6. But by the time you go beyond the 10th term, then you don't want to keep adding 6 like 10 times on that one. Well, you can maybe, but yeah, it's not that easy. I can see here the 6 times 10 plus 7 is 67, but it's always a good practice to write down the general formula and then a particular formula later. Okay, sorry, a particular term using that formula. All right, question 5, same sort of deal going on, but the common difference now is negative. So that and that. Okay. All right, question 9. Now, notice with this question, you weren't told whether this is an AP. So you got to confirm, first of all, that it Actually, no, sorry, my bad. This question actually, with this question, you were actually told that this is an AP. So now, but it's always good habit to check whether that is indeed an AP. So by checking the common denominator. But in this case, you were told that it's an AP, so you just got to check the difference between the first two, which is -3. Okay, guys. Also, the another important thing to remember is that when you work out the common difference, it's always the second minus the first term, or third term take away the second term, not the other way around. Okay, so in this case, it's negative because, as you can see, the numbers in the sequence is dropping or decrease in value. So the common difference has to be -3. Okay, and that's a little comment there that I made. You don't need to check and see if it's the same common difference with the second and the third term. Okay, so now using the formula a plus n minus d, then you get that. Okay, now the second part of this question was saying that, okay, when does this sequence become negative? So that means you need to set that, okay, the nth term less than 0. So basically you're trying to solve this inequality, okay, which gives me that, and therefore n has to be greater than 28.33, which means on the 29th term. So the 29th term is the value when this sequence becomes, for the first time, a negative value. Okay, and to work that out, the actual value, you can substitute 29 into that formula to work out the actual value for it. Okay, all right, question 10. So this time you're given that progression of this a sequence, but you were not told whether this is an AP. So you first of all need to check and see if this is indeed an AP by finding the common difference. So that's 3. That's also 3. Hence, this is an AP. And once you've made that, then when you make the conclusion, that then you can now write down the formula. Okay, because this formula, which is a plus n minus 1 times d, only works for the sequence if it's an AP. Okay, so use that, then that's that one. And therefore here, the last term you're given as 100 in the sequence. So there you go. All right, so what you need to do is you need to set that equal to 100. Okay, so then that's this, and n is a nice positive integer, so that's good. So what does that mean? That means the 34th term is 100, hence you've got 34 terms in that sequence of the progression. All right, question 12, moving on. You were told that uh, this is the sequence, and first of all, like I said, you need to confirm whether this is indeed an AP by looking at the common difference. So indeed, they're the same, hence this is an AP, hence we can write that down as the nth formula. Okay, now the next question, you were told that, okay, so which term in the sequence becomes greater than 500, and which term in that sequence become less than 850. So you can set that up nice inequality like that. Okay, so replace Tn by 8n because we now figured out the mathematical formula for it, and then solve that inequality to get this. Okay, so what does that mean? That means that the term has to be greater than 62.5. So the next largest integer, positive integer that is 63. And for this one, the smallest, actually, sorry, the large, okay, the positive number before 106.25 is obviously 106. So what that means is the 63rd term is the very first term that whose value is greater than 500, and 106th term is the very last, I guess, the last value that is less than 850. So that's what the answers are for. Okay. Now, then how many terms are there between those two values? Well, it's just 106 take away 63, and you have to add 1 to get the number of terms, not just the difference, because remember, if you just do that first two, it'll only, if you just do that, it will only give you the difference between. So, for example, how many terms are there between 1 and 3 in terms of the number? Sorry, how many positive integers are there between 1 and 3? You don't say 3 minus 1 equals 2, so hence there are two terms. That's only telling me the difference. There are three positive numbers between 1 and 3. So 1, 2, and 3. So there are three. So the way to work that out is you work out the difference between the first and the last, and you add 1 to get the number of terms. Okay. Excuse me. And now this last three questions that I picked are these ones. Question 13. So here, again, you're given it as an AP, and the nth term, or the last term, is given as 108, and you're asked to find the 20th term. So write that down. So notice we don't know the common difference, so we got to work that out. Okay. How? Well, we know that the 11th term is 108, so you substitute it in there. So 108 equals 28 plus 11 take away 1, so that's basically 10, hence the common difference is 8. Now you put back into that formula, and then substitute n equals 20 to work out the 20th term. So, okay. So the steps are, the first, you got to work out the common difference, and then whatever the nth term that you're asked to find. Okay, in this case, it was 20th term. Question 18, you were told that it's an AP, and then the 11th term is 36. And here, that's the sequence, okay? The interesting thing is we don't even know what the X value is, okay? But we know that we're told that the common difference, well, actually, we can work out the common difference because you were told that the sequence is an AP. So work that out, and nicely, 5x here, 5x here, they cancel, so it's actually 4, okay? So what that means is here the formula becomes the first term, which is 5x minus 9 plus n minus 1, excuse me, times the common difference, we just worked it out, which is 4, okay? And the 11th term is given as 36. So if you substitute all that in, then you get that, okay? All right, and then that's now 10 times 4, that's 40. So this, all of a sudden then, this becomes an equation that involves x. Okay, so then 5x becomes 5, hence x equals 1. Okay, all right, so it's the x value. All right, the last one is question 19 and part B. So the original sequence that's given. So it's all in log with the base a. All right, so got to figure out the common difference, D, first. So I'm going to take the first, take away the second one. So using the log rules, then you get this and that. All right. And then here from there to there, remember 1 on 3 is 3 to the power of negative 1. So using this part of the log rule, I can say that, okay, so that's my common difference. So now that's my little d, and hence use the nth formula for the AP, which is the first term plus n minus 1 times the common difference, which is that. Okay, then now what I've done here for the second line is you multiply that by n to get this, that by that to get log a3, and then you add this. All right, now I mean, I guess you could stop it there, but to make it nicer, what I've done is, okay, so this is like trying to make negative here and n multiply, so there's negative n log a3, and these two, because they share the same base and it's adding, so I've multiplied those two to get that. Okay, so that's a nice log rule application problem. And that about does it for this video, and I'll see you guys next time.